Welcome back, physical science class. Today we're going to be doing experiment 15.5, and here's the research question. Can the color sensors in the human eye detect color constantly and without resting? So, we were going to do 15.4 in class, but that was kind of a difficult one to do with the webcam. So instead we're doing 15.5, which is probably even easier for you actually to write a lab report on. This will be your final experiment of the year with a lab report, so congratulations on that. I hope to have your Module 14 lab reports back shortly. And of course, that means I will scan and email them to you, so be attentive to emails. So, once again, can the color sensors in the human eye detect color constantly and without resting? What we're going to do is we're going to look at one object for 60 seconds. Now in the book, and I would encourage you, actually, this is a really fun experiment to do, like it's just interesting and very easy. So I'll explain the directions in the book, and then I'll explain how we're going to modify them for doing this over the webcam. So in the book, what you would do is you would take two sheets of paper, and on one of them, and they both be pure white, on one of them you would color in a fairly thick red cross, and then you would set a timer and stare at it for 60 seconds. Then, once you're done staring at the object for 60 seconds, and again it's bright red and is surrounded by white, then you would take the other sheet of paper, which is white, and put it over it, basically replace your picture of the cross with a blank sheet of paper, and see what your eye detects at that point. What does your eye observe when you take away the red you've been staring at and just look at white? Now, you can do that on your own, and you can do it with any color you want. And for your lab report, I don't mind if you do this on your own and do it according to the instructions in the book and use any color you want for your lab report. Or you can report on how I'm going to do it, which is a little bit unconventional, but is accommodating for the fact that anytime I try to put a color marker on the board, it doesn't show up very well because of glare and because of other issues. I've been writing in black for all my classes. So this is Isaac's stuffed red panda, which he named Red. He's actually sort of pinkish, but anyway, he's very cute and soft. But the reason that we're going to be using him is because instead of staring at a red cross for 60 seconds, that would use up pretty much all of my red ink and maybe still not show up very well. So he's a very bright color, and in fact when I hold him up to the red cam, he's almost too bright for it, so he's actually ideal. And if you're looking at his back, then you're basically just seeing, oh gosh, I hope your parents don't walk in the middle of this. It just looks so weird. You would just be seeing this big red blob on a white board. So then what you'll do is you'll stare at red for 60 seconds. You can pause the video, use a timer of 60 seconds, and then start it up again. And I'll take them away, and you'll just see the white board. So when I take away the big red object and you only see a white board, what do you expect your eyes will detect? That is your hypothesis. What do you think your eyes will see when you take away the red object and move to a white object after 60 seconds? And this is testing whether or not your eye can just stare at the same color constantly and continue to pick up the color. So I won't give you any more clues as to what's going to happen. Go ahead and write your hypothesis. So hopefully you have a hypothesis written by now, and hopefully it involves both what in general you think is the answer to the research question: can your eye continually look at a certain color and detect that color without resting? And also, hopefully your hypothesis will include what you think you're going to observe after 60 seconds of staring at this red, roughly spherical object, and then suddenly transitioning to looking at a white board. So, I am going to hold red up to the camera and try to get my head out of the way. And there we go. I'm kind of bad at working with the mirror image. So I'm intentionally not filling the screen with his color. Now I'm going to count down 3, 2, 1. Let's see if I can reach my mouse from here. And when I do, oh, there we go. Okay. This is so weird. When I do, then pause the video for 60 seconds, and when you start it again, then you're going to see just the whiteboard. All right? So, 3, 2, 1. So what did you see? If you saw what I saw, then after I pulled red out of the shot and looked at the whiteboard, I saw this big blob about this area, and it was the same shape as red, but it was green, kind of like more bluish, I guess, kind of an aqua color, but blue-green. There's a reason for that. This can actually go into the background of your experiment at this point. I didn't want to give this to you beforehand because I didn't want to give you any clues for what you were going to see. But normally I would have given this to you beforehand. So in the background, section of your lab report, we can define rods and cones. Actually, we really just need cones. So cones are cells in your eyes that detect color. Rods, by the way, detect light. We're not really dealing with them. Right now we're focusing on color. Speaking of focusing, the camera just came back into focus. So yeah, cones are cells in your eyes that detect color. You have 3 types of cones, and I'm anticipating that this will not show up well on the board, but I'm going to try it anyway. You have cones that detect the 3 primary colors of light. One of them is red. Yeah, that actually wasn't so bad. You have cones that only detect red. You have cones that only detect blue. And then you have cones that only detect green. Now, Isaac's toy panda, though his name is red, he wasn't pure red. And you're not really going to see a red that's just like pure red, like only red light. Out of most of the reds that you see, I mean, you might at some point, but you wouldn't necessarily even recognize which one is pure red. What happens is when you look at a white surface and then a pure red object, then what occurs is your blue and green color sensing cones are not really being worked out. They're not really being used at the moment, they're just resting. But your red color sensing cones are all detecting this color. They're taking in the information. And it's not pure, so I mean, if you're looking at red here, let's just say that red is a combination of red color and then maybe like a little bit of blue. Then that would mean that your red cones and your blue cones are working, but your red cones are working harder than your blue cones because you're mostly seeing red color. And anyway, as you stare at a red shape for 60 seconds, for example, at that point, your cones have actually gotten so tired, your red cones have gotten so tired that they've completely shut off. And we don't know it because our brain has this mechanism that causes us to remember the red image we were looking at, even though our cones have gotten tired and are no longer seeing it. So there may have been something that happened to you when you were staring at red. If you were like me, then as you were staring at the panda, your vision around the panda started to kind of get like this blurry blue-green color just around the perimeter of the panda. Especially as you moved your head. It only really happened if your eyes or your head moved. But anyway, so I was experiencing that. That was a sign to me that my red color sensors had already shut off. Because, interestingly enough, white light is a mixture of all 3 of these colors together. So when we see visible light coming down, it's white light, but if you were to split the different wavelengths of light up into different colors, then you could divide it into, of course, the rainbow in its entirety, but but within the rainbow, red, blue, and green. So it's the mixture of all three of these colors, really all of the colors of visible light, that creates white. Excuse me. So what happens then is when your red cells, when your red sensing cones get tired, then your brain remembers the red image you were staring at, so you still see the image, but when you take the image away, then everything you see in its place is going to be blue and green. So it's actually even more interesting than just that your red cones all went off or on. As you were looking at the panda, let's say that he was covering this area of the board. You may have noticed that you could see white all around the panda the entire time. That's because as you were staring in the middle where he was, your red cones were only getting tired in this middle area of your vision. The red cones on the periphery were still seeing just fine, so you could still see red and blue and green all mixed together to make white all across the board. But in the center where your red cones were tired, then when we took the panda away and you no longer had that red image to remember, your vision kind of like reset, and everything left in the middle was only blue and green. So that's why you could see white all the way around, because all three colors of your cones were active beyond the perimeter of the panda. But then when you were actually staring at the panda in that range, your red cones were so tired that when you took the panda away, all you could see is a mixture of blue and green. Basically the opposite colors from what was removed. So anyway, that basically concludes experiment 15.5. It's all about the cones in your eyes detecting color. And the reason that your eyes can play tricks on you like this is because the cones get tired and remember the image that they're detecting, but then as soon as you remove those colors that they've gotten tired from staring at, then you see the inverse of the colors. So I would encourage you, if you want to have fun, try different colors. Like, do the experiment as described on page or on in the book for experiment 15.5, but make different shapes, use different colors, and it'll teach you actually like what the opposite of each of the different colors you use is. It's pretty fascinating what will end up happening. So with that, hope you enjoyed this experiment tutorial and all of its weirdnesses, and I look forward to receiving your lab reports. Thanks very much.